Okay, girls, right. I've no new notes today now because I gave you notes on Friday, but I didn't give you any work on the notes I gave you. So I'm just going to go over stuff from Friday, but you don't need to write anything down for the moment, okay? Because you've notes and examples down, okay? So we all learned how to find dy dx. Is that okay? Right. So what are you? And remember, I said I'd tell you how, and then I'd tell you why. Right. Well, the y is you're finding the slope. Right? So when you find dy dx, yeah, when you find dy dx, you're actually finding the slope. Okay, and as I say, you don't need to take this down because we took this down on Friday, right? But I didn't give you any work on it, so I just want to go over it. Okay, so when I say find dy dx, I'm actually saying find the slope of the line. So if I say here is a line, now, why am I confident that that is a line? Right, why is that a line? How do you know it's a line? Because there's no what? There's no, the highest power of x is just x on its own. Right, okay, as in there's no x squared or x to the power of 2 or x to the power of 3. Right, if the highest power of x is just x on its own, that's how you know it's a line. So that is a line. Okay, so if we were in coordinate geometry, you tell me, oh, that's in the form y equals mx plus c. So you'd say m is the slope and it's the number in front of x. So you'd say m, the slope of that line is 4, right? That was one way to find the slope of the line that we learned in coordinate geometry. Now we're going to have a second way to find the slope of the line. The second way to find the slope of the line is to differentiate, get dy dx. So if you differentiate 4x plus 2, you just get 4. And look, the answer is the slope. So when you get dy dx, you're actually getting the slope. Okay? So imagine if I have a second line, y equals minus 6x plus 1. Right, how do I know it's a line first? Because there's no x squared or x to the power 3 or whatever, okay? Right? Okay, so that's how I know it's a line, because the highest power of x is just x on its own. So that is a line. So my question is, what is the slope of the line? So all you have to do is find dy dx. So remember, to find dy dx of an x term is just the number in front of it. And if you find the dy dx of the number, it's 0, so it disappears. So dy dx is equal to minus 6 there. So that means the slope of that line is minus 6. Okay, right. But what if we have a curve? As in, if we have a curve that looks like this. So we'll just say this is x squared plus 2x minus 3. Okay, I just made that up now. Right, okay. So how can you get the slope of this? Remember, the slope is how steep is the line. And you're like, but there is no line. What do you want about? How can I tell you how steep is the line? Right, okay, when there is no line. So basically, on a curve, girls, the slope changes at every point. So there's the slope at that point, if it would hit the line, right? The slope at this point would be like this, okay? The slope at this point would be like this. So at every single point on the curve, the slope is different. Would you agree? Right? So at every point on a curve, the slope is different, right? So what we do is, we get, if I said find the slope of the curve, you'd say, oh, slope of a curve means get dy dx. So I get dy dx. So dy dx, what is dy dx here? Someone please answer me, because it's great to see you. Now I'd love to hear you.
2x plus 2.
Thank you. 2x plus 2, when you differentiate that. Bring the power down in front, reduce the power by 1. And when you differentiate the next term, you just get the number in front. Is that okay? So at any point on the line, right, or on the curve, the slope is 2x plus 1. So, or sorry, 2x plus 2. So at this point, just say at that point x is equal to 1. So that means at x equals 1, the slope would be equal to, this is the general term for the slope. So at that point there, 2 times 1 plus 2. So 2 times 1 plus 2 would be 4. So the slope here is 4. Okay? Imagine at this point, and I'd first say this is, at this point, x is equal to 2. So at x equal 2, the slope of the curve or the line at that point is 2 times 2 plus 2. So 2 times 2 plus 2 is 6. So the slope of that line there would be 6. Okay? If I went back here and I said this is x is equal to minus 1, right? Okay? That means at x equals minus 1, the slope is equal to 2 times minus 1 plus 2, which means the slope would be 0. Okay, so the slope there would be 0. Now it's not drawn accurately. Don't tell me that the slope isn't 0 because I know it's not. Okay, but at that point the slope would be equal to 0. Is that alright? Okay, so you can get a general form of the slope for a curve, and then you can fill in the x value to get the slope at different points on the curve. Is that okay? Right, so that's what we're doing. Right, okay, and the last thing I wanted to tell you about is, right, I've been drawing these lines. Does anyone know what these lines are called? They're called a tangent, right? So a tangent is a line that hits the curve at one point only. So that line there hits it here. That line here hits it at one point only. So a tangent is a line that hits the curve at one point only. So clearly a curve has no slope. What you're doing is you're getting the slope of the tangent at that point. So I'm getting the slope of the tangent at x equals 1. It's, sorry? A tangent is a, well, I didn't write that down for you, so I'll write it down for you now. So a tangent, you can add this to your notes. So a tangent is a line which, I'll go touches instead of hits, touches a curve so you can just write that in. Okay? So a tangent is a line which touches a curve at one point only. So here's your curve, right? This is a tangent, right? Okay? So here's a curve, right? This is gazillions of different tangents, but if I just draw in one, so if I just draw in the tangent at that point, basically the curve and the line just go through one point. They've only one point in common. Okay, is that alright? Okay, example, now tell me what was the last example I wrote down on Friday? Right, so I'll go example 3. Curve, let's y equals 2x squared plus 5x minus 4 at the point 3, 2. Okay? So basically this is a curve. I'm picking a point 3, 2 on the curve, and I want the slope of this line. So this is, I want the slope of that line. Sorry, sorry. So you take your curve y equals 2x squared plus 5x minus 4 okay? And you get dy dx, because you know that the slope of the tangent to the curve is dy dx, okay? So you get dy dx. So dy dx, when I differentiate here, you bring the power down in front. If there's a number already there, multiply it. So bring the power down in front. There's a 2 already there, so 2 2s are 4. Right? X to the power, reduce the power on x by 1. So 2 take away is 1. 2 take away 1 is 1. Right? And then differentiate 5x, you just get the number in front. And differentiate minus 4 and you get 0. Okay? So they were the 3 rules. If there's a power, bring it down in front, reduce the power by 1. If it's an x term, you get the number in front of x. And if it's a number, it's 0. So it disappears. Okay? Right. But then I said, find it at the point. So I said, find dy dx at the point 3, 2. Now, girls, remember 3, 2 is the point x, y. Now, you don't care what y is equal to. So you don't care. That 2 is extra information that you don't need. All you need, right, what do you need? You need to know at this point that x equals, what does x equal at this point? 3. That's all you need to know. So the 2 is just extra information they've given you. You don't need to know it at all. Right? Okay. So it said find the slope at the point x equals 3. So in here, everywhere you see an x, put in a 3. Remember, 4x to the power 1 is just 4x. So 4 times 3 plus 5 equals 17, and that's your answer. So the slope of that line there is 17. Okay? Is that all right? Will I do another example, or do you think you're okay? Do another example. Okay. Can I move this up? No. Right. Are we good? Right. Example 4. Find the slope of the tangent y equals 2x cubed minus 4x squared plus 3x minus 7. Okay? At the point, I go minus 1, 5. Okay, I don't even know if that point is on the curve, but it doesn't matter. Okay? Right? Okay, so what you do is the slope of the tangent, you immediately say, well, that means get dy dx. So you get dy dx. So to get dy dx, girls, you differentiate. So bring the power down in front, reduce the power by 1. So bring the 3 down, there's a 2 already there, so 3 2s are 6. So that's 6x, and reduce the power by 1, so that's 6x squared. Okay, here, bring the power down in front, so bring the 2 down in front, there's a 4 already there, so 2 4s are 8. X to the power of, and reduce the power by 1. Right? Okay, and then 3x, when you differentiate 3x, you just get 3. And when you differentiate minus 7, you get 0. Okay, so that's gone. So does everyone know how to differentiate at this stage? Right? Okay, so then it's at the point minus 1, 5. But you don't care about the 5. All you, from the point minus 1, 5, all you need to know is x is equal to what? What? Minus 1. That's all you need to know. The 5 is extra information put there to confuse you. So don't worry, don't be confused. Right? So then you go 6x. So everywhere I see an x, put in a 1. So 6 times minus 1 to be squared minus 8 times minus 1. Remember, x to the power 1 is just x on its own. plus 3 into the calculator. With that, you get 6 plus 8 is 14 plus 3. Okay, you get 17 again. Okay, that's an accident. The answer isn't always 17. Okay, I think that's what you get. Yeah, okay, is that right? It's just a pure coincidence that this one is 17 again. Okay, the answer isn't always 17. Right, you think we're okay with them? Okay, so between now and tomorrow, we're going to do page 247, all of number 1 and all of number 2. So page 247, all of number 1, all of number 2, and I'll stick it up now so you can get started. Okay. Yeah. Yes, pictures. This is page. Page 247. 247, 1 and 2. Okay? So, are you ready for me to stick it up here? Do you want a photo or will I just put it up here? Okay, stop recording now.